In the beginning of the Renaissance, many people of the Renaissance, such as kings, queens, and religious leaders, thought our existence was linked to the heavens somehow. Happenings like comets and eclipses were often thought of as heavenly events that had great significance on the people of Earth. Astronomy discoveries of the Renaissance, 1450 to 1700s-ish. The Renaissance was looked upon as the age of discovery, not only in the medical field, literature, architecture, and art, but also physical science, more specifically, astronomy. Starting in the 1450s, a man named George von Burbach was placed as the astronomer professor for the University of Vienna. Burbach began to translate the almanacs of a famous patron of astronomy, Ptolemy, and then make it available to most of Europe. After the translations, Burbach began to also address Aristotle's cosmological system and making new observations of principal stars. Through his persistence, Burbach advanced to the discovery of Halley's Comet with the Alphonsine tables as a guide. During this time, Regiomontanus, who was Burbach's star pupil, joined Burbach's research in making eclipse calculations and observations of several comets. Their combined research made up the published textbook Tabula Eclipsium. Burbach, in a follow-up textbook, explained his belief that planets were solid crystalline spheres and were controlled by the sun. Shortly after the publication of these textbooks and several others, Burbach passed away. After Burbach, Regiomontanus took his place at the university, and he continued Burbach's research with Bernard Walther. These two men developed what was called during their time a Naturalist or Scripta. This was made up of 3 notebooks of observations. Many of the observations were developed in Regiomontanus's observatory and workshop, which Walther had secretly funded. Around 1506 to 1507, and Nicolaus Copernicus began his own work. The many years of observation by Burbach, Regiomontanus, and Walther became Copernicus's framework for his attempted goal to refine the classical universe. Copernicus was a gifted scientist and mathematician, so when he received the desire to study astronomy, he moved to Italy and took up a class at Bologna about astronomy. He stayed there for 10 years. Copernicus relocated to Poland to spend the remaining 30 years of his life making observations. All his observations were put into a great book that he wrote by hand by the name of De Revolutionis Orbium Coelestium. Copernicus found that the Earth rotated on its axis every 24 hours and revolved in a circle around the Sun. Like the remaining planets, he also devised that the universe was much larger than originally thought. In addition to these claims, Copernicus broke down Christian Aristotelian thought and ideologically, and their theory. These theories are the reason Copernicus's book remained unpublished until the month of his death, mostly for fear of public, which was common and for good reason. Copernicus's heliocentric belief is shown below. Giordano Bruno, also known as the Forgotten Philosopher, continued Copernicus's work and thoroughly spread his doctrine. His ideology reached King Henry III, who had heard about him because he was thought of as an amateur magician along with Queen Elizabeth. Even though he was a famous patron of humorous speeches, Bruno was still tried as an atheist and burned at the stake. Bruno's theories and beliefs at first were thought to have died along with him, but after a very short amount of time, another man joined the scene. This man was no other than Galileo Galilei. Shortly after the invention of the telescope, Galileo became interested in the study of the universe. From then on, he perfected the telescope and began his work. Galileo used his telescope to discover not only the moons of Jupiter and sunspots, but also that the moon was not smooth, that its light actually came from the sun, which was only seen at night. Plus, Galileo discovered the phases of Venus. After these discoveries, Galileo also sided with Copernicus's theories. Which, as you just saw, the Catholic Church did not agree with. So Galileo was put under house arrest. To add to Galileo's conclusions, Tycho Brahe, who was a nobleman, began to create very detailed and precise measurements over a long period of time of the stars and planets. Brahe was alike to develop these measurements without a telescope, and was so precise that he actually calculated the planetary positions down to the minutes. His accuracy was thought to be at least 10 times better than anyone had previously attained. I would be proud of that if I were him. Brahe's assistant, Kepler, at first helped Brahe with his calculations for a short period of time, while Brahe developed his geological heliocentric system, closely related to Copernicus's calculations, and his main observations that included supernova and the orbit of comets. But after a short period of time, Brahe's assistant, Kepler, turned into his partner. Prior to Brahe's death, Kepler was given data by Brahe. To continue the observations, Kepler discovered that the distances of the planets were embedded within each other. Along with this discovery, Mars didn't orbit at a constant, meaning it did orbit on a circular path. From these discoveries, Kepler developed the laws of planetary motion along with demonstrations. Despite these discoveries, many people didn't accept this and questioned it. People wondered why movement could not be felt. Now, after many astronomers' frustration, it's time to bring in the big guns. Isaac Newton, 1642 to 1727. Newton was responsible for ideas concerning how things worked, things like calculus, nature of light, objects' movement, mass, and many other things. But the main conclusions made by Newton concerning astronomy are much, much greater. Newton developed 3 laws of motion, including the famous F equals ma, and he was also developing the laws of gravitation during this time. These laws explained past astronomers' theories and ideas. These laws proved, that's right, proved that the sun was the center of the solar system, following the 9 planets. Also, that planets orbit more of an oval shape. Using the calculations he devised, the distances of planets and stars became more accurate as well. With these formulations, all astronomers contributed to the current knowledge known today, and physics would be nothing without them. After the bombshell Newton pried open, the people finally accepted the heliocentric theory and belief, and understood the truth of the solar system and planetary positions, which is described here.
This is how it goes. The sun comes in and bees all rude and says, "Hey, all you planets, come around me." So then Mercury joins in and is like, "I'm tiny, I'm tiny. Yeah, 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 I'm tiny." So then Venus comes all in and he's all like, I'm hot. Oh yeah, hot, hot, hot." And then Earth comes all over and he's like, "Oh, I have life on me. Well, I am the best." And he's like, "Oh no." And then Mars comes in and is all like, "Oh no, you didn't." So then there's the asteroid belt. That was just a planet that exploded. So then Jupiter comes all over and he's like, "I'm the giant." Then Saturn comes in with its rings and they say it's the sexiest. But who really cares? And then Uranus comes in, so that makes a nice joke. Neptune comes over and he's all blue and all happy. And then Pluto comes in, doesn't even know if it's a planet. It's lame. And that is our solar system.
Although it was condemned, astronomy bloomed during the Renaissance. Many questions still existed then, but many questions had been answered already. The end.